Welcome to Ms. Parb's Flipped Classroom. In this lesson we're going to review factoring quadratic expressions. And the objective is to find common, which would be a greatest common factor, and binomial factors of quadratic expressions. As a reminder, factoring is rewriting an expression as a product of its factors. Many quadratic trinomials, ax squared plus bx plus c, can be factored into products of two binomials. And so when you hear this, think AC test. Okay, in our first example, we're going to factor 2x squared plus 11x plus 12, and we notice that a is not equal to 1. So we know that a is 2, b is 11, and c is 12. So AC would be 2 times 12, which is 24, and b is 11. So we want to know what will multiply to give us 24 and add to give us 11. So all of these combinations multiply to give us 24, but the only one that adds to give us 11 is 3 plus 8. So we're going to use 3 plus 8 to rewrite 11x as 3x plus 8x. So instead of 3 terms, we now have 4 terms because 11x became 2 terms. So we're going to group this. We're going to group the first 2 terms and the last 2 terms together. Then we're going to look for the greatest common factor for just this, and then the greatest common factor for this. So the greatest common factor for this expression was x. So we factored out an x, which left us 2x plus 3. The greatest common factor for this expression is 4. So we factored that out, and that left us a 2x plus 3. We now notice that inside the parentheses, those expressions are the same. So we have another greatest common factor that we can take out. So we factor out the 2x plus 3, and that leaves us this x plus 4 for our other factor. Okay, in this problem, we're going to factor x squared plus 9x plus 20. Notice that a is equal to 1. So a is 1, b is 9, c is 20, AC would be 20 because 1 times 20 is 20, and B is 9. So the factors of 20, 1 and 20, 2 and 10, 4 and 5. And we notice that 4 plus 5 equals 9. So we're going to use these two numbers. Because A was 1, we do not have to go through this grouping step that we did up here. We can go straight to the answer. We'll take the square root of this term, which is our x. And then the 4 and the 5 are the numbers that we found over here. So x plus 4 times x plus 5 is the factored form of this expression. We know it's correct because 4 plus 5 gives us our 9, and 4 times 5 gives us our 20. Okay, in this one, we have the special case where a is equal to a negative 1. And the first thing we want to do is factor out the negative 1. So that gives us x squared minus 13x plus 12. Notice all of these signs change. And so now we're going to use just what's inside the parentheses to factor. So a is 1, b is a negative 13, c is 12. AC is 12, b is a negative 13, negative 1, negative 12, negative 2, negative 6, and negative 3, negative 4 are the factors that will give us a positive 12. And then negative 1 plus negative 12 will add up to a negative 13. Since we took out the negative 1 and our a is now 1, we can just write the answer, which is x minus 1 times x minus 12. Don't forget your negative 1 is still part of your answer. In our next problem, we have 2 terms, so it's a binomial. The first thing we want to always look for when factoring is the greatest common factor. And we notice that 6 and 9 have the factor of 3 in common, and n squared and n each have an n in common. So our greatest common factor is 3n. When we factor that out, that leaves us a 2n plus 3. And that is completely factored because there's nothing else we can do with that. On this problem, when we look at this, we notice this is a perfect square, this is a perfect square, and we're subtracting. And that reminds us that we have the pattern a squared minus b squared equals a minus b times a plus b. So I take the square root of 25x squared, which gives me 5x, the square root of 49, which gives me 7, and because this is first, 5x comes first, so I have 5x plus 7 times 5x minus 7. Okay, on this next slide, we're talking about perfect square trinomials. There's a pattern that if you recognize it, it makes it easier to factor. But if it's something that is more difficult than helpful to you, then don't worry about the pattern and just factor it using the AC test like we did in the prior examples. But if you want to use the pattern, it's this. A squared plus 2ab plus b squared equals a plus b squared. So if this is a perfect square and this is a perfect square and the middle term fits this pattern, then you take the square root of the first term plus the square root of the last term and then square the quantity. This one is exactly the same, except instead of the plus here we have a minus, and instead of the plus in our answer we have the minus in the answer. So let's look at a couple of examples. 1x squared is a perfect square, 25 is a perfect square. I want to check to see if this fits the 2ab pattern. So I have 2 times the square root of 1 times the square root of 25, which gives me 10. This is 10. 10 is what I'm looking for, so that tells me that this is a perfect square trinomial, and I can factor it this way. The square root of this term would be x. The square root of 25 is 5. These are both plus, so that's a plus. And don't forget your square because it is the quantity squared. In this example, we have 1x squared minus 6x plus 9. This is a perfect square and this is a perfect square, so I want to look and see if this fits the pattern. So I take 2 times the square root of 1 times the square root of 9, which does give me a 6. This is 6, this is negative 6, so I know that it's a perfect square trinomial, but this time, because this is 6 and this is a negative 6, I will have the subtraction sign in the answer. So the square root of that would be x minus the square root of 9, which is 3, the quantity squared. Okay, here are 7 problems for you to try. Pause the video, copy the problems, work the problems out, and then restart the video to check your answers. So pause the video now. And there are your answers to the previous 7 problems that you just tried.